Okay guys, remember when we're solving logarithms that we can bounce between log form, which is log base a of x is equal to y, and its exponential form, a to the y equals x. So when we're looking at a, let's first plug in the 32. Alright, so we plug in the 32, and since we're in log form, remember we can take it to exponential. So let's go through and let's figure out what our a, our x, and our y are. So we see that a is 2, and x is 32, and y is just going to be y. So to change it to exponential, we know that it's going to be a, which is 2, raised to the y equals x, which is 32. Well, we know using the one-to-one property that if we can get like bases, then we can get rid of our bases and be able to solve for our exponents. And we need to do that because that's where y is. Y is up in our exponent right now. So can we get 32 down to a base of 2? Yes, we can. 32 is the same as 2 to the 5th power. So we know that 2 to the y is equal to 2 to the 5th. Once you get your bases the same, you can get rid of them, and you're left with y equals 5. So then when we look at b, it's the same idea. We know we're going to plug in the 1 for x, so we get log base 3 of 1 is equal to y. Well, it's in log form, so we know that our a is 3, our x is 1, and our y is just y. So let's take it to exponential form. So our a, which is 3 to the y, equals x, which is 1. Now, this one's an odd one because we cannot get like bases with 3 and 1. But there is a rule that tells us that there's a certain exponent that we can raise any number to, and it'll always give us 1 as that answer. And so this is one of those you just have to know rules, that if you're looking for an exponent which is going to give you 1 as an answer, then it's going to be 0. Okay, and C, let's do the same thing. Let's plug in the 2, and let's set it equal to y because it's log form. So we've got our a is 4, our x is 2, and our y is going to be our y. So when you set it up into exponential form, you've got your a to the y equals x, but can you get 4 and 2 to have the same base? Yes, 4 is the same as saying 2 squared, and you still have your to the y equals your 2. That 2 needs an exponent up there, and since it's not written, it's always a 1. Then remember right here, you've got that power to a power, so you multiply those two exponents, and you get 2y. So we have 2 to the 2y equals 2 to the first. Bases are now equal, so get rid of them. So 2y equals 1, which when you solve, you divide by 2, which tells us that y is equal to 1/2. And then finally, letter D, same idea. Let's plug in our x value. So we know log base 10 of 1 over 100 equals y. My a is going to be 10. My x is the 1 over 100. And the y is just going to be y. So when I go to set this up as in exponential form, I've got my a to the y equals x. Well, what's wrong? What don't you like there? Right, you don't like the fraction. So take the 100 and we're going to bring it up. How do we do that? Well, when you bring it up, remember we said anytime you cross that fraction line, your exponent changes sign. So this becomes 100 to the negative 1. Can you get 10 and 100 to have like bases? Yes. 100 is the same as saying 10 squared, and then you still have your negative 1. And just like the previous example, you've got your power to a power there, so you multiply the powers. So 10 to the y equals 10 to the negative 2. Now you've got your like bases, so you can get rid of them, and we're left with y equals negative 2. Hope this helped.